Okay.
So there's no practice test, right? It's just like the little quizzes.
Yeah. So I mean, honestly, I gave you guys like a lot of questions that are like the amount of questions I gave is worth a little bit more than a test actually, if you actually count it up. So okay, so you can do it all at once or whatever. This one has 23 questions.
I have a question. Resonance structures and isomer. So resonance, it's like the elements are in the same place, but the bonds are different. And then isomers is the same molecular formula, but you can like move them around.
Um, yeah. So I'm gonna write some definitions for you guys. Hello.
Hang on. You guys done with class or is it just
Oh no,
starting?
we're actually just starting.
Oh, what time did you guys start?
5:30.
Try to do one thing on the unit if I have time.
Oh yeah, sure. You can just try.
If you want, you come back tomorrow.
Okay.
Whatever you prefer. Come back tomorrow?
Yeah, come back.
Okay, sounds good.
I tell you, the getup makes me look like a teacher now.
Okay, so isomers, all right, basic definition is that same molecular formula, different structure. Okay, so that is an isomer. Resonance, not that was so resonance is resonance. Okay. Is simply that demonstrates the movement of electrons. Demonstrates movement of electrons. Okay, so what's it called? For isomer, let's do C5H 11O. Okay, so this is some molecular formula, right? One way you could express this is you could express it like C, 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 right? And then you could have a double bond to an O here and then have H's here. Okay, so like that would be some sort of structure, whatever. Okay, it's redundant. And the isomer of this would be simply like, let's say you do the same thing where it's like this. Instead, but now you have an O here. That would be an isomer. So basically, molecular structure, same molecular formula. Yeah, I already read that. Same molecular formula, different structure. So
Why is that not also the resonance?
because resonance only deals with the movements of electrons, right? Whereas isomers deal with different structures but the same formula. So like, for example, with like resonance, like nitrate was the example, right? So N, right, NO3 minus, right? So it would be N, O, 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 right? And then one of them would be double bonded. A resonance structure would be something like N double bonded O, O, O. And then another one would be N, O, O, double bonded O. Right? There's three resonance structures in nitrate, right? None of the atoms are actually moving, but the only thing that's changing are the electrons, right? The bonding electrons, right? What's actually happening, if you want me to draw the arrows of these things. Just gonna dot all these, okay? So what's actually happening, right, is the electrons are moving and essentially that's what's happening. So what I just drew with the arrows is, hello, Spiro. What I drew with the arrows is how the electrons are moving, right? None of the atoms are actually moving though. We're not getting some. Well, in this one, right? These are two different structures, right? The oxygen is on the second one here, but then this one, the oxygen's on the third one. Same molecular formula, right? Different structure. Okay, so do you see how what's it called? Um, if you were to count off all the hydrogens, you would get the same formula. So it'd be, yeah, let me get a better, use my colors. So it would be, um, C5H11. Oh, so if you were to count this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 hydrogens, 5 carbons, 1 oxygen, right? Same thing, 5 carbons, 11 hydrogens, and 1 oxygen. So how would you be able to tell them apart? Like looking at the structure right now. So like same molecular formula, just different structure. Yeah, but it's not a different structure. What this is showing is simply a movement of electrons, right? The atoms aren't actually moving. Like what this actually is, like I think he showed in class, is it's like nitrogen is like having all these bonds with oxygen, and then it's like kind of like a partial like thing that's happening in all of them, right? And then just these are the resonance structures, but this is like what's actually happening in real life. Like it's like a slight double bond and whatever. Yeah. Okay.
So wait, so if there's single bonds only, can there be resonance structure?
No. So yeah, if there's single bonds, typically there wouldn't be any resonance structures. Yeah. So isomers, resonance, okay? Isomers, same molecular formula, different structure. Resonance, like movements of electrons. It just shows the movements of electrons. There's no different molecule or anything. It's the same molecule, movements of electrons. All right? I have candy for you guys. You guys want to take some candy? But anyways. Oh, hello, Nisha. I can't hear you, so you have to text in the chat. What am I doing? So you want me to go over, um, you guys want me to go over like the last lecture, or do you guys want me to do the practice quiz right away?
I think start with the
Yeah.
practice. I mean, I already did it, so.
I had questions.
Yeah, questions.
Practice based.
Oh, you already did it?
I didn't do it.
You didn't do it? Right, you guys, did you guys do the practice quiz? No?
Yeah, me and Devinder did it.
Oh, okay, okay. Yeah, Anushka, I don't really. Hello, Joanne, why are you like, you just come in?
You're waiting for a sec.
What am I doing? Okay, let's just really quickly go over this last lecture that you guys did. This last lecture probably has like the math involved with this like test, but I think most of this test is gonna be concepts. Like it's gonna be molecular geometry and hybridization and all that stuff. So like I would say prioritize like the beginning part, and then some of the math is like you gotta like yeah.
In chapter 7, there's only like hybridization where you have to like find what's the hybridization of the central atom. Is he gonna ask us anything besides that from chapter 7? Cause like
Yeah,
chapter-
no, that's basically all he's gonna ask about hybridization. He
okay.
might ask like little bits like, oh, does a pi bond form from a hybridized orbital or unhybridized?
Okay, yeah, that's
So like that's whatever, but nothing too depthful, nothing too cuckoo crazy. Oh, hello guys. Hi. I can't hear you guys. This is how the situation has been doing Zoom, but what it is. What am I trying to do? I'm gonna go to Canvas really quick. NYIT edu login. Yeah, if you guys have any questions right away, like about anything in life, let me know.
So for resonance structures, can there be a major contributor or are they all the same?
For nitrate, this is the only, like, they're all the same in this case. But in other cases, there would be a major contributor. It depends on like the formal charges. So. What would be a good example? Like, yeah, like the cyanide, or HCN, right? I know, not that. No, that wouldn't be the one. What would be a good example of that? I have to look that up, but basically there is major contributors and you determine that based off of the one with the minimal like formal charge. Yeah. That's 3. Oh, okay, let's see. Mhm. How was your day, guys? You guys chilling?
I have a question. What is your hat called? Like the style?
Fedora.
Oh, it's a fedora? Okay.
Yeah, but it's not actually the hat he had in the show. I was gonna get it, but too much money, too much money. I was gonna wear a bald cap, but
What's that? Oh,
It's a cap
my
that's so
bad, my bad, my bad. I was hosting.
it came as a, you wanna see the color of it?
Yeah.
You brought it with you?
I was gonna wear it.
Wear it tomorrow.
It's so brown. It's so brown. I'm not wearing this tomorrow. I was like, I looked at this, I was like,
Can you try it on right now?
no. Everyone's been asking me to wear the bald cap, and I'm like, no, no, no. Yeah. Hi guys on Zoom. Okay. Anyways, let's go to the thing really quick. Really quick. So none of your tests is gonna have stoichiometry, so you don't need to worry about module 7. So that's okay. Screen share here. Really quickly. And then gesture show. Damn, it's the wrong one. That's fine.
Oh, yeah.
Okay, so quickly, we're just gonna go over this really quickly. And then we'll do the practice quiz. So what's it called? So we're doing the mass volume percentage, whatever stuff that is. So molarity and stuff. This is probably the most like tested like math problem you guys are gonna have, like something about molarity and like dissolving things. So you guys had like a lot of active problems on it, right? Like, so you guys need to like know how to do this efficiently and well, because like, yeah, it's all multiple choice. So none of your work that you do for the problem is gonna get like scored. It's all about just getting the right answer. So whatever way works for you guys works well. I recommend dimensional analysis, but it is what it is. This is a good formula. Again, dimensional analysis kind of, you don't really need to know the formulas, but it is what it is. It is what it is. So these are just like vocabulary words, whatever. On the last year's test, there wasn't a question on this, but he probably would maybe ask a question about it now because whatever, like, and I think it's fairly like straightforward, right? It's part over whole times 100, right? Part over whole times 100. That's something we've all learned at a younger age. Same thing with volume, right? Volume percentage. Part of volume over whole volume times 100. And then, yeah, mass volume percentage. This one is basically the amount of grams per 100 ml or something. Yeah. So like in class, we had a question where it was like 6.5%. So that would be 6.5 grams over 100 ml. Yeah, and you can use the formulas for whatever. Things. So yeah, and then this is parts per million, parts per billion. You can always, yeah, I always just know the dimensional analysis and stuff. I keep yapping about that, but that's just how it. Another way of thinking of parts per billion, in case you do use dimensional analysis for this stuff. Another way of doing them, like another way of looking at parts per million is you're doing, let's say you have like 300, let's say you have 700 like 86 parts per billion, right? Another way of looking at that is 786 parts per billion, right? What is billions of 9, right? 786 parts per billion, right? Or another way of saying it is like grams per like billion grams, which is what this is, right? It's mass of whatever, right? So way to do dimensional analysis or not doing dimensional analysis. It's just a way to kind of understand it better, or you just memorize these formulas. Yeah, you can do that with this problem if you want, but Yeah, and then the practice problems. Does anyone want me to go over any practice problems or anything like that before we start the practice quiz? Nah, you guys are chilling.
Not a practice problem, but one of the sample ones though.
One of the sample ones? Which one?
Wait, actually, it might have been. Scroll down. I'll find it.
Okay, no problem. Um, but yeah, are you guys ready to do the practice quiz and stuff? People on Zoom. Hope you guys can hear me and stuff. Yeah, I think you guys can hear me. That's why you joined, right? Um, okay. I'll move the camera so that no one sees you guys. Yeah, I'm gonna start a timer and then yeah, everything will be a-okay. Screen sharing. So, how long would you guys want to do this test? Should I give you guys 30 minutes to do this one? Because there's more math on this.
We took that.
I know you already took it, but for the ones that didn't take it, would you like time? Like how much time would you?
Which practice test? Well, like here? Or
Oh, the one I made. I mean, makes it pretty tough. Are you gonna have it? There you go, here you go, Snow. I'll give you guys 30 minutes to do this. Okay. That one? Yeah, I'll do it. Yeah, I'm gonna put a timer on, guys, but I'm also gonna be answering some other questions. So this sounds 30-minute timer. Start now. On the camera, I'm gonna be answering some questions. Okay, so do you want me to teach it the way that I would teach it, or do you want me to teach it the way like you guys learned in class? Like
Sounds less confused.
I don't know I don't know, because the way I teach it is not confusing to me, but it's confusing to a lot of other people. Oh. Can I see the problems?
Alright.
It's okay. Actually, I'll pull it up. I have an iPad. You have a laptop. Anyone on Zoom, if you have a question, please type it in the chat. I see no one texted anything, so I think you guys are chilling. But please type it in the chat.
It was on slide 13.
Okay, thank you.
The water bottle. So I understand part A and B, but when you get to C, should it be the bottom?
So I guess like, yeah, I'll explain it in terms of like the way I would do it. Give me a second. Let me pull it up. So, which part are you like confused about? Part C? So I'm gonna start from the very beginning of the whole thing, right? So you have 500 ml, right? So typically with like dimensional analysis, right, you want to cancel out these units, right? So you have 500 ml. How would you convert this to grams first off? You use the density, right? The density is 1 gram per 1 ml, right? So you put 1 ml or 1 gram, which is from the thing. It's canceled out, right? Next thing, now you have to find moles, right? So then you would use the molar mass, right? Okay, so the molar mass of water would be like 18.02 or something like that. So you want moles as well, right? So you want to cancel out grams, so you have to put 18.02 grams over 1 mole. Okay. This cancels out grams and you get moles of water. Now you have to find the water molecules. Well, we're gonna get the hydrogen atom. So for every 1 mole of hydrogen, how many moles of water? Hydrogen is there?
Say that again?
For every 1 mole of water, right? How many moles of hydrogen are there? Yeah, two. So for every 1 mole of H2O, there are 2 moles of H.
Wait, I don't get that part.
So water, right? Water has H, like two H's and one O, right? So for every one mole of, like for every one water molecule, there's two H's. Okay, right? Same thing for every one mole of water, there's 2 moles of hydrogen. Yeah, okay? So that's where I got this relationship from, because in the formula itself, there's 2 moles of hydrogen in one water molecule. Is Maryland telling me? Oh, no, I don't know, okay. I need to go to therapy. Okay, all right, so you following? So now what this calculates is it's calculating the number of moles right now of hydrogen. And so now we need to calculate the atoms of hydrogen. So what constant are we gonna use for that? Yeah, Avogadro's constants. So for every 1 mole of any substance, there's 6.023 or 2 or whatever times 10⁻³ atoms. And then you would actually multiply this all across and you'll get the right answer. Because everything cancels out, right? You're going from mole. And then you're left with hydrogen atoms. Yeah. The reason why I'm gonna recommend doing it like this is because on the test, right? He's not gonna be grading you on like finding the grams right away or finding them. Like it's gonna be straight like, hey, you have this amount, you gotta find the atoms, and then you're gonna have to do it all. Like if you do it all in one step, saves you a lot of time, effort, work, and you understand what's going on. As opposed to doing it in multiple different steps, but yeah.
Yeah.
You understand? Did I confuse you a little bit with this or? No? Okay. Does it help? Okay. Do you have any more questions? Yeah.
So,
Yeah, I know you already did the class.
yeah, okay, this one threw me off.
So
Was this from this test last year?
it was from this test
Okay,
last year.
it looked
So-
exactly like what you did.
So basically, you're adding 200 milliliters to a 2 liter thing, right? So what's the total volume? So you can't do that. That's why I like differential analysis. Because like
No,
I'm
'cause,
gonna
okay,
keep
I
preaching
didn't
it.
read the deionized water. I thought it was another solution that was already made,
Yeah.
so
Mhm.
I didn't combine them.
You have any questions now?
I mean, on this test, I like screwed up 03, but I understand it now, but yeah.
Mhm.
Like, yeah, I don't really have questions.
Oh.
The individual
Number.
So.
Number 8.
Yeah,
ppm.
So grams over. Okay. Of like whatever, right? It's
Yeah.
grams over solute over solution, right? Of some
Okay.
sort of thing, right? Okay, so what is the what is these? Let's see. So I say the human breath. It's supposed to say human breath.
Yeah, I got it. Yeah.
So 6 point, what is it?
6.27 grams.
And then what's it asking, molecules or atoms?
Oxygen atoms.
Okay, so then now it's simply 1 mole. Okay, what's the mole mass of O2?
15.99. Oh, O2. 31.99.
So 1 mole for how many oxygen atoms are in 1 mole of oxygen gas? Two. Right? 2 moles. Now, how we can calculate the Avogadro's atoms, whatever.
6.022 times 10 to the 23rd.
6.023 times 10 to the 23rd. Atoms over 1 mole. I literally chose like different values from each of these steps. So, nothing. Don't look at this side. It's an answer to a question.
Oh, I see.
Yeah, I know it's a tough question. This was actually, you know what's crazy? That was on the test last year. So you gotta know how to do that.
Yeah, I have trouble converting. And then there was another one that he put on his practice exam, which was this one. Because you were supposed to realize that it was an axiom, but it's actually saying it was a molecule fluctuate that much.
I mean, I guess that's just kind of like.
I did not know.
Oh, of an individual compound. Oh, this is the individual compound. I see. So what you want me to do this?
Yeah.
Okay.
I have like a conceptual question. It's like very quick.
What is it?
So molecules that contain polar bonds may be polar or non-polar. That's true, right?
What'd you say?
A molecule that contains polar bonds may be polar or non-polar.
Molecule that contains polar bonds.
May be polar or non-polar, right? That's true.
Yes.
But molecules that contain non-polar bonds, can they also be polar or non-polar or
No, I don't think so.
no?
No. Okay. Well. If the molecular geometry says whatever, then it is polar.
Oh, okay.
So, okay, anyways. 6.223 times 10 to the 2.
No.
We need calculators. Is 2 grams per mole. That's it. Grams per mole, molar mass. So the reason why one of the things is when you when you have kg, right, 1 kg equals 1,000 grams. So if it's kg, you have to times that by 1,000. That's why I changed it to 22. You put 28 here. But yeah.
Yeah, because I didn't know what it was asking.
Yeah, question?
How do you? I thought you would find polarity based on electronegativity. Like why?
Because with geometry causes like polarity to occur. So like, for example, like let's say, let's see. For example, like nitrogen, let's do, so you know like ammonium, right? Okay, obviously it's the ions, so the ions, but whatever, right? It's tetrahedral, right? So technically, this molecule is technically non-polar. Obviously it's an ion, but not polar, right? But then as opposed to ammonia, right, which is N. Right? So even though like obviously there is an electronegativity difference between hydrogen and hydrogen, whatever, right? But the structure itself causes it, or even better yet, like I need to see I need to print out. But yeah, electronegativity is important, but also like geometry dictates polarity. So like things like bent, right? Any molecule that's bent will be polar, right? Any molecule that is right, seesaw or T shape would be polar. Pyramidal,
I
right?
can memorize.
Yeah. Okay.
Do we use molecular structure, not electron arrangement? Is he the?
Yes. Yes. Because electron arrangement just tells you all the electron domains around it, but the molecular structure tells you like, okay, is there an asymmetric distribution of electrons or whatever?
Can you run through the molecular geometries?
Yes. I'll go through that really quickly.
Like which one's polar, which one's non-polar? I know most of them.
Yeah.
There's like one or two that. So
No one is saying anything on Zoom, so I hope that they're okay. Okay. I'll run through them very quickly. Yeah. All right, so the first one you got is linear. Okay, linear, you got linear, trigonal, planar, tetrahedral. You got trigonal, I here, ram, middle. You don't need to spell because it's a multiple choice test. Octahedral. Okay, so all of these are the electron arrangements. E, A, okay? So like carbon dioxide would be the first one, right? CO2, okay? C double bond O. Okay, so this is linear, right? So there's two electron domains, AX two. So that's it, right? Okay, so now there's two subsets in trigonal planar, right? There's obviously trigonal planar. Like this would be
Like BF3.
yeah, EF3 would be a great example. Boron is electron deficient. Or you know, carbonate would be also a good example. Carbonate would have a double bond. Gosh, something like this. This is nonpolar, right? Planar stuff is always nonpolar. Uh, yeah. So linear is nonpolar as well, typically, unless there's some difference in atoms.
Yeah.
And then same thing, this is nonpolar unless there's some difference in the atoms, right? Okay, next one is bent, so sulfur dioxide. So that's 18 electrons. Okay, so that's something like this. There's resonance in the structure, but bent structure. This is polar. Okay,
CO2 is also resin, correct?
no,
No?
because what's it called? Carbon would be electron deficient. If
You can't make a resonance structure out of CO2.
No, because electrons wouldn't want to move toward carbon, they wouldn't want to move toward oxygen. But in order to have a complete octet, you need there to be three carbon. So
But then why wouldn't you be able to switch one of the double bonds into a triple? Have like a triple and a single bond.
oh, I see what you're saying. I mean, I guess, yeah, I guess you could do something like that. It is what it is. Um, by the way, guys, I just want you to know, resonance is probably gonna be like one multiple choice question test or two multiple choice questions test. So don't worry so much about knowing whatever. You don't even need to draw them out. It's a multiple choice test. You're gonna have to pick the right answer. You have a 20% chance of getting it right. And then if you actually know your stuff, you have 100% chance. So you guys will be fine. You guys will be good. Okay, resonance is not the end of the world. This is important. Molecular geometry and stuff. Anyways, keep doing this. Okay. So this is polar. Polar, right? So okay. Next one is tetrahedral, right? Methane would be the greatest example. Everyone uses methane for this. There's a bunch of other examples, but this would be non-polar. Okay. And then the next one you have trigonal pure metal. Ammonia is the example for that. And okay, right. And this one will be polar. Then you got water, or this is dense now. Again, just like this one, except now it's there's 4 electron domains, right? So okay, this one would be polar as well. And the reason why it's polar is because of the geometry of this, and obviously the electron negativity does help. Yeah,
Xenon dichloride be meant.
xenon difluoride. Yeah, xenon difluoride would be that. So xenon difluoride, let's just write that quickly. That's xenon difluoride, 8 plus 12 equals 20. So something like this. I'm drawing this out really quickly because I've done this structure a lot for you guys, be like that. So it's the same structure as that. This is polar, as well, because it's that. Okay.
Okay.
So all this stuff you has to be in memory, okay? With trigonal bipyramidal, it's a little bit wonky. You got seesaw, you got 3-2-T. 3-2-T is the way to memorize it.
Aren't they all polar?
What's that?
Aren't the seesaw T shape, aren't they all polar?
Yeah. The only one that's not polar is the linear one now.
Yeah, linear is the AX two E three, right?
It's extreme.
Everyone, Zoom is okay. I'm sorry, guys. I neglect you guys too much. It's whatever. Oh, I should. You have more questions or anything?
Wait, so they're all over except the last one.
Yes, for right now, yeah. So unless there's a different molecule, like if they're all the same, like atoms, right? You can assume from the geometry, whatever polarity. But if it's non-polar, there's like a fluorine here, or something like, right? It would become polar because you would check the electronegativity value. Okay, so if it's all like if it's the same atoms around the same central atom, they're all equally pulling that thing like apart. Like, yeah. You're not gonna tug of war, right? And you're at a standstill, right? That's kind of what's happening with all these hydrogens. All these hydrogens, or the carbon's more electronegative than hydrogen. They're probably pulling all these hydrogens like together, needing all the. But yeah. Okay, so let's try to do some. So the PCl5, right? PCl. Not draw this well. Okay. Like this. This is non-polar. Okay. Because everything's being pulled apart properly. Then sp hybridized, sp2 hybridized, sp3 hybridized, sp3. Yeah.
Is he gonna be asking about like the vectors for electronegativity?
You're not gonna ask that. Okay, next one is seesaw. So seesaw is 4-1, right? 4-1, so sulfur tetraoxide, fluoride. Filter, that's the thing that's on the reactors, but it's okay. S4, right? 6 plus 28 is 34, so 34 electrons. Sulfur F, 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 F. 1, 2, 3, 4, 5, 6, right? 8, 16, 32. No, what am I doing? 8, 16, 24, 32. Okay, so this is an asymmetric distribution of electrons. Okay. Next one is 3-2-T, so let's do chlorine tetrabromide. So this one would be 28 electrons. Cl, ER, ER, ER. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 24. I did it right? 10. Yes, I did it right. 1, 2, 3, 4. So why I keep saying 3-2-T? 3 3 atoms, 2 lone pairs, T shape. So 3-2-T. That makes everything here easy because 4-1 that has to be seesaw, 2-3 has to be linear. Because that's just what makes sense. If you know 3-2 is T. Good question. Okay, I'll get back to it when I open this. Yeah. So yeah, and like when you breathe, what I'm trying to say here, this is a question on the last one. So when you breathe, 70 grams of like the atmosphere. Okay. Okay. So what's it called? Shoot. I'm just going very fast. Okay. What am I trying to do? Okay, so next one's linear. So this one's I don't know which one's this one. Which one would be good? I don't know which one would be a good linear one. Okay, I3 minus. Okay. So okay, next one's we'll do. So this one's under this column is linear. So it's still the electron range is still trigonal bipyramidal.
I have a
So
question about the electron, the polarity. So what if it's what do you call it? You know when it's like you have the central atom and you have 5 electron domains, but you only have like 2 actual atoms attached, and you have 3 lone
Pairs?
pairs?
I'm about
Is
to
it
draw
polar?
that. It's non-polar.
It's not.
So I3 minus it's an ion, so it acts like an ion, but the structure shows it's non-polar. So it's I. Okay, so wait, how many electrons is this? So
21, 22.
22 electrons. Okay, so right, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 8, 8, 16, right? So there's 6 electrons left, so 1, 2, 3, 4. Okay, and linear is not polar because there's an even, everything's pulling it apart evenly.
Oh, never mind.
So yeah, with it's all like cohesive, right? A molecular geometry with linear is still non-polar. So it's all like it all cohesively makes sense if you think about it. Like all bent stuff are polar. All the things with pyramidal is going to be polar. We're going to go into that right now. So octahedral SF6 is a good one. So it's S, F, 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 F. Yeah. So if you were to count this, it would be 48 electrons, right? 8, 16, 30, 24, 32, 40, 48, right? So this is octahedral, this is non-polar. This is sp3d2 hybridized. Everything in this column except linear would be sp3d2 hybridized. This would be sp3d hybridized because it's under this technically, but I didn't have to. The next one you're going to draw is square pyramidal. The square pyramidal, I don't have an example of that. But square pyramidal, bromine pentafluoride. So bromine pentafluoride is a good example of this. So there is 42 electrons. Okay, so there's I don't know what it is then. So yes, it's okay. So the PR don't need to worry about drawing because it's a multiple choice test. So I'm not gonna draw it one. I don't have to draw one.
Should I do the short response questions on use of practice tests? One that he provided.
Yeah, because those questions literally could just be made into multiple choice questions.
Oh,
Okay, so it would be something like this. Because 8, 16, 24, 32, 40, and then 42. Okay. This is polar. It's this is square planar pyramidal. Pyramidal. Okay. So anything that's pyramidal is polar. And then the next one's square planar, which is non-polar. So this goes under octahedral, still 6 domains. What's an example of this? Okay, I gotta go quickly. Xenon, penta. It's been a long day, guys. Okay, xenon F4, right? 8. 36 electrons, right? Xenon. So the way that this would look in space. It's not. Okay, 8. So I'm not drawing the electrons if you guys haven't picked up. So it's 8, 16, 24, 32. How many electrons? 8 plus 28 is 36. So there's 2 more lone pairs left. So it'd be like this. And this is non-polar. And that's it. So let's see. How can I make this look aesthetically better? Or not? This is like this, okay? All this stuff. Okay. Okay. Does that make any, like, did that clarify anything?
Yeah. Let's take a picture.
Okay. You want me to dress up for the picture? Okay, okay. Okay, wait, I gotta look like Breaking Bad. Wait, I gotta be this. I gotta have a serious face. Wait.
Wait, here's what?
Oh, sorry, guys. Okay, all right, okay. All right, and 9, 8, 7, 6, 5, 4, 3, 2, and 1. We're done. Okay. How was the test for you guys?
Is there an answer sheet?
Yeah, I sent an email. I got the answers already because I'm locked in, guys. So you guys got to be extra locked in if I'm locked in. Okay, so you guys are leaving? Okay.
Yeah.
See you guys. Have a good day. What am I trying to do? Oh, yes. iPad.
Thank you.
No problem. So I can be like Yusuf and plug this in. Hello? Don't look at that. That's something else. Yeah, this is it. Nope, that's not it. Oh, this is it. Okay. What am I trying to do here? Oh yeah, I need to join the Zoom. Give me a second. Zoom. Are you guys doing okay? Is there any like specific questions you guys have? You guys are just chilling. You guys are tired. How's calc today? Tired as always.
Actually kind of nice.
Really?
Yeah.
I'm surprised. I think I'll join my meeting. What is this called? It is called something. 597 385 4660. Number 4 on there. I'll go over everything. I know I made a really tricky test. How do you guys feel about the practice quiz? Like, was it a good difficult, a bad difficult, an okay difficult?
Oh, yeah, I had a question about one of the questions on the practice list. So pretty much, it was for number 8,
Number 8? Okay, I'll go over it.
right? It's still,
Okay.
I got D. I'm not sure if that's the right answer or not, so I'm not looking at that, but,
Okay, well, let's look at it. This was
is D correct?
1 second. For which one? Number 8? It is D.
Okay, but I got 9.13 times 10 to the 60. It's just
10 to
because I
the
got
60?
9.13.
10 to the 60?
Yeah, I got 10 to the 16 instead of 10 to the 19.
That's interesting. Okay,
I don't know how.
so I'm gonna erase the answers because you guys have the answers, and I'm gonna show you guys how I would go about doing this test. Should I do that? Okay, that's okay. You guys can check if I'm doing good at my job. Okay, so question one, does anyone have any questions about this one? Or like how to do it, how to solve it, any sort of practice tips and whatnot? This is
The answer for that? Can you put up the answer sheet? Thanks.
it's the yeah.
Okay, cool.
So basically you want to find the moles and you also want to find the number of oxygen atoms in those things. And so what you find is that sodium oxide only has 1 mole of oxygen per mole of sodium oxide. And then yeah, am I muted on here or wait? Should mute on there. So then people okay. Okay, so yeah, so basically you find that this is the lowest amount, so C is the right answer. Okay. There's probably gonna be a question like this on your test, so keep it up to mind. Okay, so this question I literally took from last year's test. It's probably gonna be a question like that.
Oh, number 2? I
Yeah.
got that one wrong.
So yeah, this one's a little tricky. So what you want to do is you can't really do the dilution thing formula with this. What you need to do is you need to calculate the moles. So first it's 2.00 liters times 0.4 molarity, right? And you can get 0.08 mole. And then what's the total volume, right? You are adding it to a 2-liter thing, but you're putting in 200 milliliters, right? So it's actually 2.2 liters. And if you do the calculation, it would be A. 0.0363. Okay. You guys got it? Okay. That's like 10%. All right. So this is also a question on the last year's test. It's just I changed up the molecule slightly. So which of the following molecules is expected to have an exception to the octet rule? Anyone have any questions about this? Anything like that? Yeah, BCl4 has a lone pair on it. Okay, please on Zoom, if you have questions, send in the chat. Appreciate you guys. All right, so I went over this right now, but the hybridization of the central atom in sulfur tetrafluoride would be D, sp3D. And there's a lot of cohesiveness with like the Vesper and like the valence bond periods that like anything that is trigonal bipyramidal in this like row will have the same hybridization. So like this phosphorus would still be sp3D, right? The sulfur would also be sp3D. And it corresponds with the electron array. So I think that's pretty cool. What happened? Oh, it just turned off. All right. That was an overreaction. Oh, people know the password to me. All right. Okay. No one see it. Okay. Give me one moment. See. Okay. I'll bring the candy tomorrow, and everyone can be happy. That's good. Okay. All right. Five. So this is based off of six, right? What is the method geometry? And
Wait, what was five again?
Five was just like sulfur tetrafluoride. What's the hybridization of that?
Is it C?
It's D. Because it's C cell. So it has a lone on it. It has 4 electrons. Adds 4 atoms.
Oh, we don't lone pairs.
Yeah. So the lone pairs are also an electron domain. Yeah. That's what it's just saying here, right? Everything has a hybridization. Right. Yeah. Yeah, double bonds don't contribute to hybridization, right? Like a pi bond is a hybridized thing, so it doesn't actually contribute. But anyways, So this is based off of whatever. So I'm testing this. This wasn't a question. I'm trying to you guys just know what it is. So B is seesaw and polar. Tetrahedral. And non-polar is correct. T-shaped. Is T-shaped non-polar or polar? Polar, good, right? Bent's polar. Square planar is always going to be non-polar. Anything that says planar is going to be non-polar. Okay. And I'm just into this, right? Anything that has planar is like polar is on. So that's good. This is a very hard question. This was actually a question of last year's test. The only difference was that I asked a little bit of an extra step. I asked specifically oxygen atoms. Yes. Nitrogen molecules, something like that. So for this, I always do dimensional analysis. I don't I don't know how to explain it. I mean, I could explain it with whatever formulas you gave, but it's just easier to slow down. Because the point of reason why I'm gonna keep emphasizing it's a multiple choice test. Your work is not graded. You need to do things in the most efficient way possible. And if you do things in multiple steps, you're gonna get confused. Especially because it's just a multiple choice test. And you gotta get doing it one step is very cohesive. So yeah. Also, it says break. It's supposed to be breath. Yeah. So I'm gonna write it here. The way I would write it is it's parts per million. So it's 387 grams over 10 to the 6 grams of solution. Okay, so the solution would be the atmosphere. Okay. And so every time you take a breath, you're breathing in 6.27 grams of the atmosphere. Okay. So you would actually multiply this by 6.27 grams of solution, right? Which is the atmosphere. And this cancels out with this. Okay. Next thing you do is you convert the grams to moles. So 1 mole, how many moles of molar mass of oxygen gas? Anyone tell me? Molar mass of oxygen? Yeah, 32. 0 grams, right? So that cancels out with this. This is O2 by the way. So next we're trying to see the atom. So how many moles of oxygen atoms are in 1 mole of oxygen gas? 2, right. So for every 1 mole of oxygen gas, there's 2 moles of oxygen atoms. All right. So O2. Right. Now we use Avogadro's constant. So 6.023 times 10 to the 23 mole atom over 1 mole. And then everything cancels out. And then you're left with atoms. So the correct answer would be D.
You did it the way that ink how did you do it?
The way you do it in class is you do it in multiple steps. So it's PP equals grams of whatever of solute over grams of solution times 10 to the 6, right? So grams of so this finds out the whatever. So you kind of use basic algebra. So the grams of solution that you're given is 6.27 grams, right? After telling you what's in the atmosphere, and then every time you breathe, right? You're breathing in the atmosphere. So it's kind of like a little bit of common sense there. Like yeah, that's literally how it was worded on. It's just tough. So that's why I gave it to you guys. Kind of annoying. So yeah. And plus if you're breathing, right, you're not breathing all oxygen, right? You're breathing in some nitrogen, some whatever in the air, H2O, right? So yeah, this would be the solution. 10 to the 6. And then this is 387. So you do algebra. You find the grams. So then you get the grams, and then you do the normal stuff. You convert it to moles, then you convert to like oxygen moles, and then atoms. Okay. Yeah. But essentially, like this is simplified into that because parts per million is parts over million stuff. Okay. Moving on. So these are some true or false questions. So nitrogen contains two it contains two pylons and one signal. So pretty chill question. This is testing mass percent. I realize I didn't put a lot of mass percent on here. You're gonna be a couple of mass percent questions, which is not bad, but just parts over times 100. So this is true. 40%. Ionic compound conductive as a solid, that's false. They're only conductive as a liquid or as a solution, aqueous, free flowing. And then this is false. Barium carbonate, right? Carbonate has covalent solids in it. So ionic and covalent. All right. Any questions? guys are so like tired. Are you guys like how do you guys feel like wake up, wake up. Wake up, wake up.
Eyes are open.
Guys are open, but they're not saying anything. I'm just putting in, I'm trying to give you energy. No one's getting energy. It makes me sad. It is what it is. Okay. Here's some questions about whatever about isomers and stuff. So which of the following are isomers, right? You basically the reason why I keep emphasizing same molecular structure, different. Same molecular formula, different structure. It's because this question is really probably gonna get on the test. Where it's gonna give you molecules, and you have to count it, and you're gonna see it's an isomer, right? So all these are different molecules. A and B are isomers, and C and D are isomers. So the answer is C. You have to count everything in these. Okay. All right. 14. How many sigma bonds are in compound B? Simply just counting them. You have to know what sigma bond is. Sigma. The symbol for sigma is this or something. Symbol for pi is this. You probably ask instead of saying sigma, he's gonna say this. Where to know the symbols. There's only two of them, so one of them. The other one. What was the hybridization of the most central carbon compound B? So that would be this carbon right here, this middle one. Oop. Right here. So that would be SP2 trigonal planar. So lone pairs, double bond should be anything. And yeah, even though this molecule looks like it's like not trigonal planar, it is trigonal planar. It's just drawn correctly, technically. But it's yeah. So 16 and 17 are like a little bit of. They probably wouldn't ask like instead of asking about like the number of liters, instead of asking about the liters in from the stock solution, what he would probably ask directly would be about how many solvents would be added. So like I asked it like this kind of teach you guys or like make you guys know the tricks like that, stuff like that. So what you want to do is you want to find the number of moles in this thing. This is the dilution, but I just like to use differential analysis. So 0.4 liters times 0.3 mole over liter times 1 liter over 5 mole, which is essentially B1 equals C2, right? Equals and then yeah, to convert the milliliters to milliliters. And then you get 24 is the answer. And then in order to make a 4 milliliter, you have to add of that solvent you have to add 376 milliliters. So to make 400. So it's really just understanding the atoms and things. Just applying. That's simple addition. Scientist wants to make a solution of 8.50 from 5. So I'll do the math here. 8.50 over 100 milliliters, grams. So if you're given 5.3 liters, you have to convert that to milliliters. So it'd be 543 milliliters, right? Okay, so then that's basically it. Yeah, you convert this to this, and then you get grams. So what is that? It's D, right? Is that D? Okay, good. That means I did this. Okay, this was literally a question straight from the test. It was actually an MCAT question. So this is yeah, not bad. So which of the following combinations is an ionic one? So francium is actually the most least electronegative element on the periodic table. It's on the furthest left. It's like down there. Coins up here, down there. So it has the lowest ionization energy as well. So you guys haven't learned that yet, but it's pretty cool. Francium iodide would be the answer. So D. And then O3. It's in the atmosphere, whatever. A lot of these questions on the test, you're gonna see there's a lot of fluff to them, and you have to just figure out what's being asked. So he'll give you like, oh, here's a drug, whatever, right? Who cares what the drug is? Figure out what's being asked, right? So this is O3 that's what the geometry I'm trying to arrange it. So O3, I'll draw it really quickly. So it's 18 electrons. So it's like this. Uh, uh, guys. Okay, so it's like that. Resonance form would be. There's only two resonance forms. I know this is an easy one. Still resonance.
Question, how much oxygen, the middle one, how can I have three bonds?
Oh, I mean, I know the form was written, whatever, but that's just how it exists in nature.
How do we determine that? Isn't oxygen have two bonds?
Yeah, typically it would want to have two bonds, but for some reason we have the ozone layer that has O3. And they figured this out chemically or experimentally or whatever, but there's three oxygens. So this is the structure that we would probably be that.
Okay.
Yeah, there's two. So yes, D is the right answer. How many total non-bonding electrons? This is actually a question. I think he probably asked on the final, but it's like based off of this stuff. So non-bonding things would just be the lone pairs. And remember, I'm not asking about lone pairs. I'm asking about electrons. So 1, 2. So it can't be. So the answer choice is A. Okay. So non-bonding things are things that are not bonded. Okay. All right. How many total resonance? There's two. Said that. Right there. And then which of the following statements is /R regarding the characteristics of molecular compounds in comparison to ionic compounds? I'm asking this because this is like I know this is probably something you wouldn't focus on while studying, but it's important too. So yeah. Molecular compounds have weaker bonds, but ionic bonds, they're direct transfers electron. Molecular compounds are sharing so they're weaker. So B would be the false thing. Okay. So got through the practice quiz. How are you guys feeling about it? No comments, guys. Like nothing.
Nice quiz.
Nice quiz.
Thanks for making it.
Of course. I would like rushing this whole morning because me, I'm busy. I'm a busy man. But yeah. Like, does have any questions?
What's your costume supposed to be?
My what?
Your costume.
Walter White.
Oh, right.
Walter White.
The glasses were different. That's
What do you mean the glasses are different? The glasses are the same.
Usually they're like shaded.
No, those are.
No, the glasses are the same like when he's. No, I always shades.
Oh, you always saw him with like the drawing, right? Like draw like this, and like shades on him, or something like that.
Probably.
I don't know. That's okay. But yeah, I'm gonna let you guys go early so you can study. I'll be here. One question. Sorry for feeling a little. I'm just myself. I'm wearing this the whole day.
Question. Are you on the canvas?
I am on the canvas.
Okay, cool.
I can't see anybody's grades though.
That's
So
it.
maybe I
No, that's fine.
Yeah.
I just
Have a good day. Bye, Nishi.
going in this and the what do you call it? The exam.
Okay. Answers. So let's do that. I'll stop sharing here. I'll leave. Okay. Please take candy. I know it's not Halloween yet, but
Take the whole bag?
no. If I'm giving tomorrow, then everyone can come. So let's go to Canvas. Yeah, I really think that a lot of the questions I put on this test is gonna be kind of like that, in terms of the math at least. the molecular geometry stuff, look at the other practice two stuff. Yeah, it's probably gonna be more molecular geometry, so please study that, please, your team. I want some,
Hey, how are you?
yum.
Which one's your favorite?
I like cream cheese, I'm on a basic.
You don't like Kit Kats?
Yeah, okay,
What about almond joy?
I'm allergic to almond,
Oh,
you know. I know,
so you have to eat all the almond joy before you have to take it back.
yeah, take almond joys, guys. No, I bought this, guys. I bought this for you guys. So you want me to go over the practice quiz? I mean, the exam?
Yeah,
Okay.
pull up the answer key, I guess. I don't know, I haven't checked my answers yet.
Yeah, I remember this. He literally gives the same practice quiz every year. Okay, which one do you want me to go over?
Just, can I just quickly see the answer key so I can like mark off what questions are right or wrong?
Uh-huh.
I haven't marked off whether they're right or wrong yet. My answer.
Have you guys done this yet? You guys have done it? Okay.
Like I answered them all, I just don't know if they're right or wrong.
Oh, you can't see the screen.
Yeah, no.
Oh, okay. Yeah. So this is whatever.
Wait. Let me see.
If there's any questions you guys want me to go over, please utilize this resource. Yeah.
I got A for 3.
This is my favorite, dipole element, right?
Which one?
Which was
So we have- But it was one of the questions. Does that just mean that which one's polar?
We do that?
Yeah.
I got A.
Check it.
I don't have. Do it all in my head.
One thing about this, if you guys want like a little bit of a trick, obviously you should just check every question, but PBr3 is very synonymous with NH3 because, right, halides only form one bond, right? And then phosphorus is under nitrogen, so you could like, instead of drawing it out and taking like a minute to draw it out, you can enter it like in a second, you know that. Yeah. Yeah. Oh man, I'm so excited to get rid of this mustache. I'm gonna look great. I'm gonna look great. I'm gonna look like a normal kid now. It's gonna be great. Still you guys. You know that? I'm like your age. That's part of being an SI, I guess. Okay. All right. Gonna keep going. How many lone pairs does you guys like hang out outside of school? Do you guys like study all the time?
If something has a dipole moment, that just means it's polar, right?
Yeah.
Okay.
That's like your mom just asked. You guys like,
Question.
yeah.
For number 9, is it only trigonal pyramidal? Or can it be like tetrahedral?
Divine was describes a polar molecule.
Features.
So yeah, like I was saying here, like it doesn't have to be trigonal pyramidal, but based off the options that they gave, it's the only option is trigonal pyramidal. So if you look at all these things, right, all the base things are nonpolar. So like linear, like carbon dioxide, that's nonpolar, right? Boron trifluoride, that's nonpolar. Tetrahedral nonpolar. Trigonal bipyramidal, also nonpolar, right? So all these bases are like nonpolar.
But what if you have like a different molecule on top of the tetrahedral?
Yeah, then it's like whatever, but the question's not asking about that. The question's asking which of the following molecular geometries, right? It's not asking about specifically like atoms. So like, don't get it twisted. Take it safe, take it face value. For those kind
I see.
of. I'll be waiting for you guys. I'll be standing outside holding a sign. You did well. Good job. I'm joking. for the bio.
I feel like that would help more for the.
You guys take it in like different rooms, right? Or where do you guys take
Yeah,
it?
we take it in Harry Share 130.
It's weird.
It is.
That's really weird. I'm sorry you guys have to take reuse next semester. I'm really sorry. I really sucks. Because bio two was actually kind of tough in terms of like the second test for bio two was really tough. Because like we had the easy teacher, but yet
Yeah.
the highest grade for her class for some reason was like a 93 or something like that, which wasn't not bad, but like she gave everyone like a +7 like curve and stuff.
If only Ruiz is teaching, maybe he'll be more mean. If only Ruiz is teaching
It's
like
actually-
bio two.
Oh, he's more of a nicer.
Maybe he'll be more mean, because I think right now they have an agreement of some sort.
Oh, interesting.
Yeah, I think enough people bothered him for him to next semester at least consider getting a curve or something. Like consider it.
Okay, well, good luck, guys. What's your, you want me, what's your bio lab, teacher? Yeah, who's your bio two lab next semester?
Dr. Kingman,
I have no idea.
he's new, he does.
Oh, then you're probably chilling, hopefully.
Very, like, he doesn't care about anything. Yeah.
What time?
Um, what is it?
When, like in the afternoon?
Bro, you just study all the time?
Is that
Kind of, yeah.
I mean, it is what it is.
Consider it actually as like a second option.
Go and enjoy life.
It's like-
After the test tomorrow.
It's a good idea. We'll have bio.
We have bonds,
Yeah,
we
but-
don't know what exactly.
After
what to do,
tomorrow's
but, like, he's
test.
not like.
Go to
And
finish.
and our calc.
Grading.
Oh, is calc like kicking your butt a bit or?
No, I just like, I have to study.
It's good. There's more to life than studying, guys.
I wish.
You mean I wish there is?
Ha ha ha. You know you're funny, right?
I'm not funny. I'm telling you the
You're
truth.
so funny.
That's why I'm here and you guys like I'm enjoying this. I'm enjoying watching you guys. That's a joke. That's a joke,
Exactly.
guys. That's a joke. You guys aren't suffering. You guys are learning. You want me to keep going?
I'm going.
Are you going?
Alright, dude.
Did you do well?
Stupid mistakes.
Yeah. Yeah, that's a good thing to say. Stupid mistakes. So they're just stupid mistakes. You're actually you have the potential to get
No,
them
it's a
all right.
mistake that I really wouldn't have done had I.
Yeah, exactly. So you could have gotten 100, but then you made stupid mistakes. But it's
Yeah.
stupid mistakes. Like it's like
So I can easily correct.
yeah. So like if you
Careless.
didn't make those stupid mistakes, you get 100. It's not like something you just didn't get. There's no disconnect. You know?
Exactly.
Yeah. That's the point.
Alright,
That's
so
what I'm trying to say. Okay, so you guys want to like? Do you guys have anything you want to do? I went through everything I wanted to do. So, anything? Any questions?
as I put bio two.
No, actually, it probably would be a good idea, but I don't think I'm good enough for that.
I think you're great.
No, but bio two, I don't know anything. And I don't know anything. I don't remember anything. I took the class, like literally. Okay. What's it called? The only one I would consider is being your Chem 2 one, but you guys have to understand, I'm also like, I'm gonna play the card. I'm like in my second year, you know, I'm gonna be busy studying for the MCAT, whatever. I know you guys are scared, but you know, sometimes you just gotta lock in. Is no one in here? Oh, I feel really bad. I need to figure out how to do better with Zoom people. I'm gonna stop sharing. Let's see.